Solving a system of nonlinear equations. So first, what do we mean by a system of nonlinear equation? A system of nonlinear equation indicates that one of the equations given in the system is a nonlinear equation. For example, it could be equation of a circle, ellipse, parabola, etc. So we're going to start with the first example. So we have x squared plus y squared equal 20 and x squared minus y squared equal negative 12. Notice we can solve the system using the addition method. So we're going to go ahead and add the two equations. And by adding the two equations, we obtain 2x squared equal 8. By dividing by 2 on both sides, x squared equal 4. Therefore, x equal plus or minus 2. Keep in mind that we still need to solve for y. So we're going to substitute x squared in one of the equations. Subtract 4 on both sides, therefore y squared equals 16, therefore y equal plus or minus 4. Now we got two values of x, two values of y, it means we have 4 points. And the 4 points are as such. Now if we solve the system using graphing, we're going to see also the 4 points. So this is x squared plus y squared equal 20, and the other graph, x squared minus y squared equal negative 12. And these are my 4 points. Now another example, we have a parabola and a straight line, and we need to solve that system. And notice it can be solved using the substitution method. So we're going to substitute y in the first equation. So we obtain x squared plus x plus 4 equal 10. That's a quadratic equation. You need to set everything equal to 0. So we're going to subtract 10 on both sides. So we're going to subtract 10 on both sides. So we obtain x squared plus x minus 6 equals 0. This can be factored. Then by the 0 property, x equal negative 3 or x equal 2. Keep in mind, we still need to solve for y. So we're going to substitute x. Now we need to solve for y. So we're going to substitute x by the two values we got. So this is my first point. And this one is my second point. Therefore, the 2 points are as such. We're going to see the graph. So this is my parabola, and this is my straight line, and these are my 2 points. Now in example number 3, we have another 2 parabolas, and we need to solve the system, and notice it can be solved using the substitution method. So we're going to go ahead and set the two equations equal to each other. So this is my first equation, my second equation, and we're going to set them equal to each other. So we're solving them using the substitution method. X squared can be cancelled on both sides. And from here, solving for x, we get x equal negative 1. Now we're going to substitute negative 1 in any equation. I chose the first one to solve for y. Therefore, y equal -6. Therefore, the solution is -1, -6. Another example, we have a circle, center origin, and radius 5. And another equation. Notice we can simplify the second equation by dividing every term by 2. So it will become -x squared minus y squared equal 8. And we're going to add the two equations. So we got 0 equal 33, and that's false. It means no solution. We have a parabola and a straight line, and we're gonna solve that system using the substitution method. So we're gonna replace x by y plus 1. So notice our system was x squared plus y equal 29 and x equal y plus 1. So we substituted x for y plus 1. Now we can FOIL y plus 1 squared using this formula, and then simplifying and combining terms, we're gonna get y squared plus 3y minus 28 equals 0. This can be factored, and we got two values of y. We got two values of y. Now we need to solve for x. So we're gonna substitute two values of y in the second equation. So for y equal -7, x equal -6, and for y equal 4, x equal 5. Therefore, the 2 points are as such.